Alright, let's continue with our second day of mixed review. Question number 1. So let f be a function that is differentiable for all real numbers. The table above gives the value of f and its derivative f prime for selected points x in the closed interval, -1.5 to 1.5 inclusive. The second derivative of f has the property the second derivative f double prime is greater than 0. That means second derivative is positive for this interval. So now A, evaluate this integral, show the work that leads to your answer. So let's take a look at part A. So we had 0 to 1.5. So f prime of x is a function given the table. There's no actual equation. And then 4 is a number. So therefore, because there's no actual equation, you cannot really integrate directly. So we're going to separate this into two integral. So we're going to have 0 to 1.5, 3 f prime of x dx, because this is a plus, I have a plus sign. So they keep the same number 0 to 1.5, 0 to 1.5. Now let's take a look at the first integral. So we have a number 3 times the f prime of x. So I'm going to put 3 in the front of the integral. So as soon as we do that, you realize that we can use the FTC to rewrite this. So 3 times this equal to the entire derivative f at 1.5 subtract f of 0. So this is FTC. The entire derivative of f prime of x is f. So you're going to have f of 1.5 minus f of 0. Now we're going to go to this side over here. Because this is the integral of a 4, and 4 is a number, so we can integrate. So 4x, because the derivative for x is 4. So here you get 4 times 1.5 minus 0, because 4 times that is 0. So now we are going to use our table and find what is f of 1.5. f of 1.5, get 1. Negative 1, and then minus f of 0 is -7, and then this multiply gets 6. Now we're going to just do computation. So we're going to have 3. This is going to be -1 plus 7 equals 6, and then we're going to multiply. So you're going to get as that. So we get 24. So therefore, number 1A, the answer is 24. Now let's go to part B. Part B, the question said, write an equation for the line tangent to the f at the point where x equal to 1. Use this line to approximate the value of f of 1.2. Is this approximation greater than or less than the actual value of f of 1.2? Give a reason for your answer. So for part B, step number 1, we had to find the tangent line. Step number 2, we had to do the tangent line approximation. So this part is at tangent to the graph. So to the graph of f of x at x equal to 1. So we say x equal 1, y equal to f of 1, because f of x is to the f of x. So we have to use f of 1. So now we are going to go to the table and see what is f of 1. So now we can see f of 1 is -4, and the m will be f prime of 1. So we're going to look at what is f prime of 1, which is 5. So now we are going to do y equal to mx plus b. And the y is -4, m is 5, x is 1. Now we solve for b. So now we are going to say the tangent line is y equal to 5x minus 9. So now we are going to do the tangent line approximation. So we have f of 1.2. So therefore we're going to say f of 1.2 approximately equal to 5 times 1.2 minus 9. You multiply, you get 6. 6 minus 9. And then you subtract, you get negative 3. So f of 1.2 is approximately equal to negative 3. Now the question also asks you to determine, is this approximation greater than or less than the actual value of f of 1.2? So let's refresh our memory. We say that if the graph is concave up, then the tangent line will be below the curve, then it will be underestimate. If the curve is concave down, and the tangent line is going to be above the curve, so the tangent line approximation will be overestimate. So we need to know the concavity of the f of x. So when we read the question in the beginning, we know that the second derivative is greater than 0 is positive. So that means the graph is going to be concave up. So we say because the second derivative is greater than 0 means positive, for x is going to be in this interval. So f of x is concave up. The tangent line is below the curve. So the approximation is less than the actual value of f1.2. So it's less than the actual value of f of 1.2. So we finished question 1b. Let's go to part C. Part C. The question said, find a positive real number r having the property that must exist a value c, and c is between 0 and 0.5, and the f double prime is equal to r. Give reasons for your answer. So part C, f double prime c equal to r. We don't know what r equal to. Okay, and if you look at this structure over here, it looks like the mean value theorem or the intermediate value theorem. So you don't even know what the r equal to. So there's no way you can do the intermediate value theorem. And then we have the f double prime c is the derivative of the f prime of x. So f double prime of x is derivative of f prime of x. So the mean value theorem tells us to use slope. So now we are going to find the 2 points. So let's use these 2 points, 0 and 0.5. So we are going to use the endpoint. We always use the endpoint. So we have f prime of 0, f prime of 0. So let's see, is 0. And f prime of 0.5, which is 3. So now we say that f double prime of c is equal to the slope. Okay, so we say f prime of 0.5 minus f prime of 0 and 0.5 minus 0, because that is 0.5 and 0. Now you get 3 minus 0 and over 0.5. 3 divided by 0.5 equals 6. So now f double prime of c equals 6. F double prime c equals r. So r equals 6. So what theorem do we use? You have to call it at the end by the mean value theorem. So sometimes people may put at the beginning. That's okay too. So we finished part C. Now let's take a look at part D. Part D. Part D, the question said that let g be the function given by g of x equal to this piecewise function. The graph of g passes through each point x f prime of x given in the table above. Is it possible that f and g are the same function? Give a reason for your answer. So we know that this is a piecewise function. So let's take a look at what kind of function the f is. F, okay, is a function that is differentiable. Differentiable means continuous and slope exists everywhere, okay, in this domain. So therefore, f is continuous for all x value and f has slope for all x value. So now, if you look at g over here, it's a piecewise function. So we can see that g of x is continuous. Not, we always check the endpoint, okay, or the point that is special. So now we know that 2x squared minus x minus 7. You plug in 0, you get -7. And then you substitute 0, you get 0 plus 0 minus 7, you get -7. So definitely it's continuous at this point. And of course, it continues for all the points before 0 and continues for all the points greater than 0 because it follows the same function. Okay, so it's that the g pass through all this point that the x comma f of x given the tables. That only can tell us that, okay, g of x is continuous and they have the same y value of f of x. But don't forget that f of x is also differentiable. It means the slope exists. So now we're going to see if the g of x is differentiable. We talk about that for piecewise function, we always have to check the special point. C is going to be differentiable. We know that the slope for the f at 0 is 0. It exists. The slope is 0. So over here at the 0, does it exist? So now we have to take a look at the left-hand slope. So you can think about it in your mind first. So you get 4x minus 1. And this one is 4x plus 1. When you substitute 0, then definitely you don't have the same left-hand slope and the right-hand slope. So that means g of x is not differentiable at x equal to 0. So g of x is not the same function as f of x. So after we analyze this, so now we're going to show our reason. Okay, so you say g of x and f of x are not the same function because g of x is not differentiable at x equal to 0. So now we're going to prove our reason. Okay, give a reason. Prove the statement that we just have over here. So we had left-hand derivative of g of x at x equal to 0 is so the derivative of the first piece, and then we have 4x minus 1 at x equal to 0, and then 0 minus 1, you get -1. And the right-hand derivative of g of x at x equal to 0 is then we say that the left-hand derivative not equal to the right-hand derivative at x equal to 0. So g of x is not differentiable at x equal to 0. So this going to be the detailed notation for the left-hand derivative and right-hand derivative. If you run out of time, you don't have to write so much detail. You can write less. You can say the left-hand derivative equal to -1, okay, at x equals 0, and the right-hand derivative equal to 1 at x equals 0. So left-hand derivative not equal to right-hand derivative at x equals 0, and then g of x is not differentiable at x equals 0. So we prove that g of x and f of x are not the same function.